Good evening. Well, the space age is well and truly underway, and unmanned probes being sent out to various worlds, not only Mars. We'll be talking to Dr. Helen Walker of the Rutherford Apple Laboratory to give us the latest news, and also showing you the final entries for our Mars competition. But first of all, some news notes. Remember the annular eclipse of May the 31st? Well, it was quite well seen from Scotland. We showed some pictures last time, but we have some more now that have been sent in. First of all, here's the view from Fort Augustus, a lovely ring of fire. Then down now to the Isle of Skye, where it was well seen. Down south, the eclipse wasn't annular, it was partial, and this was the view as seen from London. But the best views of all were seen from Iceland, and that's where Douglas Arnold was, and took this lovely series showing the annularity and also lovely cloud formations. Well, it was a great success, and it'll be a long time before we see another one of those. Also, looking forward to next May, we may, I say may, have two naked-eye comets. We can't be sure. Comets are like politicians, most unreliable, but we could be lucky. An interesting note here, in the southern hemisphere, there's a bright star called Achernar. You can't see it from here. It's 145 light years away. And it's been studied with the VLT, Very Large Telescope in Chile, and found to be flattened, like this. It's an extraordinary thing. We'll say 145 light years away. And now, on to our main theme. Mars is very much in the news, and in the late evening, you can see it now shining down very brilliantly from among the faint stars in Aquarius. And various probes are on their way there. Mars Express is one, carrying Beagle 2, and Beagle will actually land on Mars on Christmas Day. NASA has its two rovers, Spirit and Opportunity. But our next program, an extended one, is going to be all about Mars, so what about other worlds, other probes? And a welcome return here to Dr. Helen Walker. Helen, welcome back. There's plenty going on, isn't there?
Yes, thank you. Well, having had the success of Mars Express, the European Space Agency are now going to build another probe, Venus Express, and because they're going to model it on Mars Express, it will actually be launched in 2005 towards Venus, which is a world we know very little about because of the clouds.
Not a very pleasant place.
Not really. There have been, of course, some missions, and the most famous one was Magellan, which has mapped the surface. And it's a very unpleasant place with carbon dioxide, hydrofluoric acid, hydrochloric acid, all sorts of noxious substances in the atmosphere.
Not the place to go for the weekend.
Not really, no, and no lakes, just lots of volcanoes, and this was what the Magellan mapper showed us, were volcanoes all over the surface. It's not like Earth where we have the movement of tectonic plates and the ring of fire and regular volcanic eruptions and earthquakes almost every year. In Venus, it's completely different.
One thing does strike me, though. In size and mass, Venus are almost perfect twins, but they're so different simply because Venus is closer to the Sun. And had the Earth been 20 million miles closer in, you and I wouldn't be here.
Certainly not, and we wouldn't be able to breathe that atmosphere either.
So I think Venus is not a world to visit. Now, of course, European Space Agency, they've got their own plan, the smart probes.
Yes, these are the advanced technology missions, and the first one, Smart 1, is going to be launched at the end of August, heading for the moon, and it's going to be having a completely different way of propulsion. This is going to be the solar electric propulsion, which will actually gradually move the probe satellite out towards the moon. And so instead of taking 3 or 4 days like the Apollo astronauts, it's going to take perhaps 16 to 18 months to get there. But it's all because of this new propulsion system which we want to test. And once we get to the moon, we're going to have various little experiments on Smart 1 which will show us how the composition of the moon varies. If you think back to the Apollo astronaut days,
Yes, indeed.
We remember it well, but of course they went to certain limited parts of the moon, the flat bits for a start,
Yes, indeed.
and the side facing the Earth. And we know that the other side of the moon is very different. And although there have been sort of missions like Clementine mapping the moon, We still don't know very much about the composition or where it came from.
You know, Clementine, that probe of the 1990s which went there and reported ice inside some lunar craters. Well, I don't believe a word of it, do you?
I'm not sure. They certainly found something which is interesting and must be followed up. And the instrument that my colleagues at Rutherford Appleton Laboratory are working on, it's called DKIX. This is an engineering model of
Is it life size?
It's one of the actual engineering models, so this is exactly one-to-one. This is very close to what the final model will look like. And what we have here is just one set of detectors. There's sort of three. They're X-ray detectors, and these are just sort of demonstration detectors. There'll also be a very thin collimator on the top of this. And when the DKIX gets to the moon, it's actually going to measure the composition of the moon using solar X-rays. But of course it will do the whole moon,
yes,
near side, far side, poles, equator. That is actually going to look for mainly things like iron, aluminium, magnesium, but they're also hoping they might be able to do a little more work on whether there is any water, ice or hydrogen atoms.
If there's ice on the moon, I'll be very, very surprised. How could it have got there? Anyway, and what about Mercury? Not explored recently, and the same claims were made there, and I can imagine nothing more unlikely, but Mercury is going to be a target too?
Indeed it is, and there are parts of Mercury where there is never any sunlight, and so there are actually parts of Mercury that are very cold, which is totally bizarre on a planet so close to the Sun. But likewise with Smart 1, a lot of that technology will be used for another mission by the European Space Agency called Bepi-Colombo. And again, the solar electric propulsion will be able to take the actual satellite close to the Sun, to Mercury. Bepi-Colombo won't be launched until about 2011. And when it gets there, there'll be 2 orbiting satellites and hopefully a lander as well.
Well, only one probe had been past Mercury so far. That was the 1970s, and showed again a very uncomfortable kind of world, not too unlike the moon in many ways.
That was the amazing thing of these pictures that came back from that early probe. They showed a very cratered world, and nobody's been back there. The European Space Agency are going to go back with Bepi-Colombo. In a few years' time, the Americans are going to send a satellite to Mercury called Messenger, and that hopefully will get there about 2009 and will do some mapping for about a year. So when the European Space Agency go, they'll have a better idea of what the whole surface looks like, rather than just the thin crescent we're so familiar with.
Of course, Mercury again, virtually no atmosphere, very close to the Sun, certainly not a world to visit. Now, let's go right out into the depths of the solar system. Now, what about Galileo to Jupiter? That's been a tremendous success.
Galileo has been a wonderful success. It's been at Jupiter for many years now, and the mission is now finally over. On the 21st of September this year, Galileo is going to take a dive into the atmosphere as its sort of grand finale.
It's done its job.
It certainly has, and whether we'll be able to see sort of a kind of bruising effect on the atmosphere as we did with the Schumacher-Levy comet.
I remember that very well, the comet plunged into Jupiter. You know, you could see those marks with a tiny telescope. I used the Greenwich telescope, then my own, and through the finder of my telescope I could see those marks. Imagine what would have happened if that thing had hit us.
It's amazing, and it was surprising just how long those sort of bruises lasted. They were very visible. You know, that was back in 1995 when Galileo had just arrived, and of course Galileo dropped a small probe into the atmosphere and managed to find a dry patch with no clouds to go through and monitor the atmosphere as it went in. Since then, Galileo has looked at all the various moons of Jupiter, at least the Galilean satellites, the inner ones, and we've had the most amazing pictures from them. The sort of Io with the volcanoes.
It's an amazing place, the most volcanically active world we know. The sulfur volcanoes are right also moving right in the middle of Jupiter's lethal radiation belt, so we're going to go there.
We're not going to go there, but of course there is one of the moons that we really would like to go to.
Europa.
Europa has proved to be an amazing place. We're fairly sure there must be liquid water underneath the icy surface. It might be 100 kilometres deep. There are certainly features on the surface of Europa which look like ice cracks where things have split and reformed. And you do get tides on Europa because it has a slightly eccentric orbit.
Any comparison here with our own Lake Vostok under the ice in Antarctica?
We think it might be like that. The ice could be quite thick or it could be quite thin. The other possibility is that it might be like the very depths of our own ocean, where you might have some kind of sort of vent from the interior.
Hydrothermals, yes.
And as on the Earth, when you have the black smokers at the bottom of the ocean with sort of peculiar life forms that don't need light, on Europa you might again have a life form that can live at the bottom of this sort of ocean, heated by tidal stresses in the actual moon rather than by volcanic.
I must say I'm a bit sceptical because there's another moon too, Callisto, same kind of thing.
Yes, it's certainly the case that with Callisto again, thanks to the Galileo probe, we've actually got an idea that that may well have, shall we say, perhaps slush or some kind of icy water. It's very lightweight and it's the natural explanation.
Of course, you've got to remember these satellites are of planetary size. I mean, Callisto is very nearly as large as Mercury and Ganymede is larger.
Yes, it's the case. They are very big, sizable moons.
Far beyond Jupiter, the ringed planet Saturn, not visited by a probe since the Voyagers, and how long ago that seems. But now, a new spacecraft, Cassini-Huygens, is on its way there.
The Cassini-Huygens satellite is out there. It's going to get there at the end of 2004. And when we get there, the Huygens probe will be launched off from the main Cassini satellite. And the Huygens probe is going to try and land on Titan.
Titan, Saturn's biggest satellite, again bigger than Mercury, with a dense atmosphere, rich in nitrogen. And I wonder what the surface is like. Is it going to be ice, is it going to be rock, or are there chemical oceans there?
We hope there may be oceans of ethane there. There certainly could be weather on Titan, just like there is on the Earth, with sort of rain of ethane and clouds. What has actually happened is, because it's got an atmosphere, we can actually land the probe using a parachute. And before the probe was launched back in 1997 on the Cassini-Huygens satellite, they actually tested the parachute. They took it to Sweden, and the probe was put on the parachute, and it was sort of launched, I think it was something like 37 kilometres above the Earth's surface. And when it landed, they did try and look after it. It landed on snow, and just at the last moment a second parachute was released because, of course, Earth's gravity is much larger than Titan's. But they know that the parachute system works, and it can actually bring that probe down onto the ground at a speed the probe can survive.
One thing does strike me, though. Cassini-Huygens has been a long way on this journey, had to go by a rather circuitous route, rather like going from Brighton to Bognor by ways of Grimsby. Well, when it gets there, it'll drop Huygens onto the surface, and the Huygens probe will transmit from there, but only for about half an hour before it goes out of range.
Yes, yes. That's a sad bit, but of course, you know, that's going to be half an hour more than we've ever had before, and we will get the 2.5-hour descent as well. There'll be transmissions then telling us about the atmosphere that the actual probe is travelling through, so it really will be a very valuable actual on-the-spot measurement. Cassini will then do a kind of global mapping while it's doing its mission, so we'll then have a whole series of sort of views from outside the atmosphere taken by Cassini.
And then, of course, the orbiter will go on and survey the other icy satellites, which are fascinating worlds.
We know very little about the other satellites of Saturn, and so it's going to be really interesting to see what's going on there and explore those. And of course we've got the rings of Saturn as well, which will be very exciting.
Well, of course, as far as I know, this probe, Cassini-Huygens, is going well. Is that correct?
That is certainly correct. And in 2000, Cassini passed by Jupiter and the cameras were switched on, and so we have some very interesting pictures of Jupiter taken by Cassini, and we're now just starting to get those very first pictures of Saturn. It looks rather similar to the pictures from your own telescope, but I think the rings are at a slightly different angle from anything we've ever seen from Earth, so it's definitely getting closer to Saturn now, and the cameras at least are working, which is good.
Well, Galileo was a success. We hope Cassini will be, but not all probes have had smooth passages. The one hasn't, of course, is the Japanese probe, Nozomi, on its way to Mars. That's not going well.
Well, it's perhaps a case of success being dragged from the ashes of disaster, because when it was launched, it went into a kind of Earth orbit and failed to, the burn didn't work properly, and so it used up too much fuel. But they've recalculated the orbit, and it's now just passing Earth on its way out to Mars, and it should get there around about sort of Christmas time like the other satellites. I think it's early January Nozomi will get there, but we don't know whether the instruments will work. There was a bad solar flare.
Not bad like that.
Yes, it seems to have affected the heater for the fuel, so it may well be the fuel's frozen solid and it won't work, but that'd be a shame.
Hope for the best, I must say. Now, what about comets? I mentioned earlier we may have 2 naked-eye comets next May. They won't be as good as Hale-Bopp, but they'll be there anyway. But probe to comets. Remember Giotto for Halley's Comet?
Oh, that was a spectacular mission. I was lucky enough to be at the Aztec headquarters when it happened. It was very exciting, but of course we saw these jets of material coming off the comet, and you know, we want to know more now, and so the Rosetta mission was postponed, but it will go now in February 2004. They've got a new comet for it, and of course the problem now is it was difficult enough to say Wirtner. We now have a much more complicated name for the comet, Churyumov-Gerasimenko. We're calling it the Russian comet at the moment. We've got a year to learn the name. It's
Gerasimovich, yes.
And that's where it's going. Now the problem is, in actual fact, that this comet is a bit bigger.
Yes, indeed.
And so there is a slight concern that it will sort of come down with a harder bump when the actual lander arrives. But once we get onto this comet, we have all these exciting experiments to do there, and one of the experiments that my colleagues are involved in is this instrument Ptolemy, which is a model here loaned to me by Martin Worley at Rutherford Appleton Laboratory, and this will actually measure isotopes on the actual surface of the comet, so it's going to be very exciting when it gets there.
What about the Stardust probe?
Stardust is actually chasing a comet, and it's actually going to sample the material from near the comet and bring it back to Earth, and there's a kind of sticky pad of aerogel which is getting actual particles, pristine particles from the comet, and these will be brought back to Earth and actually tested in the lab. So it'll be very interesting when that gets back.
Also the rather startlingly named probe, Deep Impact.
Yes, the European Space Agency have a wonderful idea that you land gently on the comet, and as David Southwood said, you scratch and sniff. The Americans have taken a slightly different approach. Deep Impact is going to throw a huge mass of metal at the comet. It's going to smash into it, and they will then sample the gases and debris that come off. Rather a different approach.
And finally, another curiously named probe, Genesis.
The Genesis probe is actually out at the first Lagrangian point between us and the Sun, and it's taking pristine samples of the solar wind. Again, it's already done its first orbit around L1 and taken some samples, again with this kind of sticky pad, and it will take a few more samples and then it will come back. I think it's next year it's due back. And again, we can take these into the lab and actually study these you know, under laboratory conditions.
Well, you know, there's a tremendous amount going on. People tend to think Mars and Mars only, but not so. There are probes into all kinds of worlds, and we're learning more all the time. Did you think progress will be as rapid as this?
I'm very much surprised and very pleased at the number of probes that are being launched, and also that, you know, we're having a kind of planned campaign. We're doing Mars, the Moon, Venus, Mercury, Jupiter, Saturn. You know, it's a great time. It's a new age of planetary exploration.
It certainly is. Well, Helen, it's been delightful to see you. Thank you for joining us again, and we'll see you again very soon. Helen, thank you very much. And now, back to Mars. As I said, our next Sky at Night is going to be an extended one, all about Mars, but we have had our Mars-based competition, judged by David Hardy, and, well, you may like to see the finalists. David, you know, we had over 60 entries for our Mars-based competition, and the standard is pretty good. So, first of all, let's look at those of the over 16s.
This one I like because It's very obviously Mars with that lovely red desert. Nice contrast between the base and this aerial vehicle.
That's good. Next one.
Again, this shows a nice imaginative looking Martian base. It isn't based on any NASA designs or anything like that, but
no. It was good anyway.
Yes, it's quite nice.
Right, number 3.
And again, a nice astronaut in the foreground with a faceplate of his helmet.
Yeah.
What I like about this also is this rather jewel-like effect he's got on the Martian base. It's quite nice.
The next one is quite different.
Yeah, I particularly like this. You've got the flags of all nations on the bases here, including even the Union flag. There's even a junk pile here. Look, a scrap heap of some kind.
Very well done, very
It's
detailed.
a very nice piece of work.
Now let's look at those that have been sent in on disk.
This is quite a nice one. What I particularly like about this is the sort of wind farm he's got there. A whole lot of wind generators.
Well, they would work on Mars. After all, Mars' atmosphere is not negligible.
No, indeed. It's a nice piece of work with a lot of domes interconnected, solar panels in the background, and then at the bottom there he's done 3 sort of thumbnails with aerial views and close-ups and so forth.
Yes. Number 7.
This again is unusual because he's done a 360-degree panorama.
I like phobos in the sky.
Yeah. I guess it's sort of twilight evening, isn't it? The sky's rather dark, so that's quite nice. And I think the idea of an astronaut in a nice brightly coloured green and yellow suit is good, because on Mars, you'd want to be good visibility.
Oh, it's a very good one too.
That's a particular favourite of mine. It's a very nice technological one. You've got a volcano in the background. You've got some really, really nice looking technology there.
This is good.
Yeah. And then we've got an animation, life on Mars. And then we're zooming across the desert, actually getting closer and closer. Moving into the main base itself. Small domes, large domes, quite intricate.
Quite a colony.
Going over the top. Then we finish up with a view in the reflective view in an astronaut's helmet. Excellent job. And finally we've got a lovely digital view of Mars with a nice futuristic looking rover. And
I like that very much.
It says the Moore Canyon Village home pod.
And those are our 10.
And that's the lot.
And now it's up to the viewers to vote for the overall winner.
Yep, indeed.
And we had an under 16 category as well, and we've selected 4 of those.
In some ways, I think the younger ones were more imaginative than the older ones. He's obviously made a good attempt at drawing the Martian rocks. There's domes which have trees inside them, which is a nice idea.
Yep.
Little television aerial there. That's quite nice.
This one from an older entrant, I think.
Nice shadows.
Yes.
There's a NASA blimp, a dirigible floating in the sky there. Again, one of these satellite dishes or aerials on the horizon. And a very nice effort, I think.
A much younger entrant here, I think age 6.
Yes.
Very good effort there, I like that one.
It's got lots of things in there. Little people walking around down the bottom.
Yes.
Yep. Nice
one more?
One more. A very imaginatively used silver paint or ink on these
Yes, indeed, very good.
Angular domes. A nice little rover, possibly based on Pathfinder.
It's well done anyway, most imaginative.
Yeah, quite nice.
Well, David, a lot of entries. I think a pretty good standard.
Indeed.
Certainly better than I could do. And many thanks indeed for judging it for us.
It's been a pleasure. Thanks for inviting me down.
I think those entries are very impressive indeed. But one has got to win. So you can vote for your winner by putting it on our webpage, www.bbc.co.uk/base. And next month, we'll announce the winner. Meanwhile, it's newsletter time. If you want your newsletter, then send your stamped, addressed envelope to newsletter number 90, Sky at Night, BBC Birmingham, B5 7QQ. And when we come back next month, we'll be doing a special extended programme about the search for life on Mars. Until then, good night.